Okay, so first of all, we'll have to reinforce the elements at the bottom, and then we can go upwards with the reinforcement. There are two types of reinforcement. We can reinforce linear elements like the columns and the beams and the ribs,
Yes.
and 2D elements, which are the shear walls and the plates. We'll start with the easy part, which are the vertical elements, and we'll continue with the walls and the slabs. So we'll pick up
Yes.
this simple column, and there are some minimum percentages needed in order to fulfill Eurocode requirements. Do you have any proposal for reinforcement for this column, or would you like us to do it from scratch? Do you have a way you would prefer to reinforce this one, or would you like us to reinforce it somehow from, let's say, from scratch, not based on a sketch you have? So we're going to
Yes.
reinforce this first column, and for this we'll go to concrete 15, and here we have some options. We can do some reinforcement design, and then, or we can change some, we can input some reinforcement and check it. There are here some design default values for beams, for columns, and if we keep it to advanced, we'll have all the necessary setups. Now, the reinforcement can be on rectangular, circular, oval, or any other shape. So if you'd like automatic design, it is good that we offer a layout of stirrups for the model. So if I go into design defaults and go here, I have edges, and I can say what I would like to design. So I would like to design only reinforcement on edges. How many type of reinforcements?
Yes.
And then it will complete with stirrups. So I can either let the
Yes.
program put reinforcement bars, or I can put them myself and have a good dimensioning. So
Yes.
okay, I can choose anything for now. You'll need a lot of bars as you have very big column. And we can see the internal forces, we'll say current, from the classes, and here we'll see some redesigned forces. So this will be the design moment of the column, and if we go to preview, we have here a table of recalculated forces. It's recalculated because it takes in consideration also the second order effects. So they're a bit higher than the original ones, at least for moment. And it can also do a slenderness check. It's quite pointless for your column as it's very big section. So it's no problem of slenderness here. So it will say a limit is 19 and your slenderness is 15. So it's no problem.
Yeah.
And then we'll go to reinforcement design and refresh it. And we'll see here values. We'll need to see what reinforcement we would need to fulfill the envelope of combinations. So this is only a theoretical reinforcement. It's not like how we are going to reinforce it, but it's something to begin from. So it, let's say, provides a minimum reinforcement that would satisfy the condition. It says at least phi16, like this, but this is not okay from provisions reinforcements. So it's not okay at this point. So how I propose is to do a reinforcement model, check it, and then optimize it, as it will have a good final practical solution. So my approach is somehow different. In Romania, because of the seismic forces, we have some minimum detailing percentages which are higher than Eurocode 2. So we will start reinforcing this column. I say new reinforcement, I click on the lowest point, then on the top, and then I will choose a template. We will need stirrups, so I'll try with at least 3 stirrups, a model.
See?
What? Okay.
The all three.
Okay.
Yeah.
Actually, I'm going to show you how I can create
Yes.
a model of my own. So I'll go to edit, and I will add the stirrups that I need. So I can add here some extra points. I'll go to stirrup shape, new stirrup. Actually, I'm going to add some edges. I'll say 25%. Add another one, 25 from the end, 25 on edge number 3, and again 25 on the ending. And I'll say new stirrup. I'll go through this one, and again new stirrup. No, not new stirrup, but add some edges. So I choose edge 2, and this value is actually a percentage. So 0.25 means 25% from the beginning. So it doesn't matter the size
Yes.
of the column or the rectangle, it will adapt to whatever size. So this is a good advantage when we can take the reinforcement cage from one column and apply it to another column which has different geometry.
Yeah.
Okay, so I'll add those points also for edge number 4. Okay, 25, and I'll build another stirrup. So I just say new stirrup, connect the points, and I get the new stirrups. I'll hit OK. It's not yet the real column. I will delete all the longitudinal reinforcement from this, and I'll choose something else. I expect for your building to have at least V25 at the corners, so I'll say diameter 25, and I'll say then add bars to corners. This is available because I deleted the other longitudinal bars, but now the software will place these rebars. Here I can see a total for one selected layer or a total for the entire section. So you'll need to have some minimum bars for your section to begin, and then we can add more. So I'll add an intermediate V20, one intermediate bar here. I'll say new layer, then I'll go here, new layer again, and on these edges, new layer, okay, okay, and I'll select always from the defined template. Okay, and this is just a simplified representation. I can select here, select view parameters for all, concrete, and here I will select reinforcement drawing 3D and color by diameter. So now we'll be able to see the reinforcement in the model, and we can edit also the stirrups. Let's say on this area maybe we would need phi 10, and we will change the stirrup zones. For the first level where the shear force is big, we can have small distance, and then we will, at the other endings, we will make some adjustments. So we won't have only on the first floor, maybe we will use this small step, but then we'll divide this stirrup area into 3 regions. On the endings we'll have small steps, and in the span we'll have bigger steps and maybe smaller diameters. So I will test as I drew. So I have a proposal of reinforcement, and now I'm going to check it, and if it's not okay, I can edit it easily. In my
Yes.
country, I told you we have some minimum required, which are above the Eurocode minimum required because of the seismic forces. So it's easier for me to do the minimum required by our code reinforcement and check it, and if it doesn't check, then add more bars or change diameters. In order to check a column, I have to go to reinforcement check, capacity diagram, current, and I'll say refresh. And I have 87% for this reinforcement, so it's 87% usage. If I go to preview, I can see here the, let's say, a report of this check. I have a description of the section, the longitudinal bars, the stirrups, the cover. The cover is set up by the concrete setting, and if I want
Yeah.
more data, I go to output and select detailed. And here is the combination that did the dimensioning. We can see it's one with wind and another is gravitation. So here is the combination that was relevant. Actually, you see it's a big combination. And also the second order effects are taken in consideration, and also the imperfections are taken in consideration, because for this type of high building it is important to take in consideration also imperfections. And these are the forces in the column, the axial force and the 2 bending moments. And these are some parameters about the interaction diagram. So this is where our section is placed in M resultant and N for axial force. If it's within the circle, it's okay. So as long as any section is within this curve, everything is okay. Also here, if we are within the curve, everything is okay. So we can even try to reduce bars if you need. So for instance, I can try and edit these bars, maybe convert them to 20 to see how they handle. So if I go to these bars, I select them like this in the 3D model, I can then change from the properties. We'll go to lower, let's say 22. I can then check again the column. It's 88%, so it's closer to the limit. Okay, so basically the column is okay, and we can see how other columns behave if we apply the same reinforcement let's say, model. So we'll first check the base, and then of course we can go with the reinforcement vertically. Although the bending moment will decrease, also the axial force will decrease, so it should be checked a few floors above as well, because the small axial force would cause smaller resistance. So we'll go back to concrete. And I can apply this model to all the other columns. So to do this, I have to select the column, right click, say copy, add data, and select the other columns. And then hit escape. It's identified all the other columns. I just have to click OK.
Yes.
And it will adapt this type of reinforcement to all the other columns. And now I can check them all. I just select them. I can also use a filter to select all the columns. Go to capacity, capacity diagram, ULS, ultimate limit state, current selection, and hit refresh. Actually, I'm going to set here the brief output, refresh, and then I can see in a table the exact usage, and also graphically now the software calculates all the columns for all those possible combinations. If you remember, there were a few thousand combinations, so it's quite a big effort it does, and it does quite fast. 4 by, it's almost, there's only one column left to be checked now, and it checks the columns in multiple sections, so it works quite fast for what it provides us.
Capacity response and capacity diagram is the same, or
No, it's not the same. So
for is one for use for beam and
yes,
diagram used for column?
so capacity diagram is for column because it uses the interaction diagram where it is inputted the axial force and the bending moment. So
And
it only checks
yes.
that every section is placed within the diagram, and this is suitable for elements where we have big compression and also bending moment. However, for beams where we have small compression force, the capacity response is a better solution, and this capacity response actually
Yes.
checks the maximum deformation or deflection in the reinforcement and in the column. So it analyzes the equilibrium of forces per section. So both approaches are Eurocode compliant, but basically this is for beams, capacity response is for beams, while capacity diagram is for columns. Okay, I should have clicked there. I'll go refresh again, and we can see here the extremes per, let's say, member. So for each member I can see the usage of it. If it's under 1, it means that the section has fulfilled its enough reinforcement in that section. If it's bigger than 1, it means that the required forces are bigger than the capacity. So where we have red, we need to change the diameter. So I'm going to remove from the selection the green ones. I'm holding control and select the ones that are okay, and then activity by selection to make sure I see only these ones. So I'll only have to solve the columns that do not check. I'll remove this one as well. And now I have to increase the reinforcement. So it was quite a big exceeding here. So I'll switch them back to V25. And also for this one, I think I'll do the same. So I'll make first of all everything to V25. So I just select the rebars, go to the properties and change here the diameter to 25. And now I can check this one. Okay, it's still not enough, and I can change the number of rebars. It's okay to do this because we have a lot of space here. So also I can check how it looks from a detailed point of view. So I'll go to detailed. To see where is the problem, if the axial force is too big or it is just a problem of placing more reinforcement. The problem on this column is the fact that it has two moments, so it has moment on two direction, and the axial force is smaller than a central column, like the first we tested. So this is why this is more vulnerable. So we can see here some checks, so everything is exceeded. And you see that it doesn't have a very big axial force, this column. So it's quite vulnerable. We'll increase the number of bars. So I can select here this middle bar. Although these bars won't provide much leverage, so one approach would be to change the stirrup. So I'm going to do like this. I'm going to select these bars and then change this to 3 bars. So I change the number in the properties, and also I'm going to increase this stirrup to make it let's say closer to the edges, so I'll have bigger leverage arm over it. So the way I'm going to do that is I'll say new longitudinal bars. I select the column. I'll start from point 0 to the top. So the longitudinal rebar, I select the element from the base to the top, And here I can say edit stirrup, and I can change this to be 0.2. So by changing this, I'm increasing the leverage arm for all the stirrups. So
Yes.
I can have more room to place bars. I hit OK, and you see now that it's updated. I'll just hit OK. Select the model, and we go here, check capacity, and refresh it. Now it's 96%, which is okay. So this is how we handle the problems. But you have to do the other reinforcements. So I gave you an example, a few examples, and now you'll have to go and follow upwards the structure, change the reinforcements. So it's better to start with many bars and then start reducing them once you go on top. So after you get on top, you should reduce bars. Some columns disappear, I know, in your model. So, but mainly you'll do like this. You first establish the base cages, and then you'll go upwards level by level, and you can check them. So you make sure that everything checks okay. You can either work on all your columns like this, or analyze the diagrams and see which have the biggest forces on them. So it's up to you if you reinforce all your building. Of course, the program might run slower if you do this, or you can choose the most relevant columns. You see here we have too many bars, but you decide whether you want symmetry, you want to reinforce them the same, or if you want more optimized, you can start reducing the number of bars, and you might have a better solution. So more economic solution. You decide, but you'll have to pick up this. You just add elements upwards and try to find a safe and economical solution. So this is how you'll this will be your homework, let's say, until we'll meet again, to analyze all the columns of your building. So you play around until you get an optimum, and then this is how you go up and reinforce everything. Save the model.